Good evening, everyone. Today is Tuesday, 3/24/2020. I'm going to start the lecture for tonight. We're going to go through functions. So the material I have posted already, and we're going to go with the lecture, starting with the difference between the global variables and local variables. After discussing the difference between global and local variables, we're going to discuss the scope of the function, because when you're inside a function and the local variables that are defined, and normally they are being used locally, and then the outside of it is globally. We will go through examples on those ones as well. So let me go with the difference between global variables and local variables, and to demonstrate, I'm going to show you this function global variable versus local variables, which you have the PDF file, and inside that PDF file, basically, I'm showing you the full scripts as well as the examples for it. So in this script, what we are learning is how to start scripting with the first line and indicating what interpreter I'm using. In this case, bin bash is my interpreter, and it's installed in the bin directory. So I'm using the shebang symbol, which is a pound bang. That's called shebang in Unix, and then that one tells me to find /bin bash as my environment. Then I just have like some comments with pound sign on the second line and third line, saying script name, what's the name of the script, and what it does, the purpose of the script. So after having these comments and explaining it, then I write prints each arguments. Actually, print each argument is a continuation of that line. So the first thing that I do is assign $1, which is passed from the command line as argument, first argument of this script, to arg1. And then I'm writing a bunch of echo statement to say where I am in the script. That way, every time we print out this information, it will indicate where you are at what line or what part of the script, whether you're outside of the function, you're inside of the function, you're in the global area of the program where you're. So right now, this statement is outside in the main program. And then I start a function usage, which basically is going to check for the number of arguments passed on. And if the number of arguments as passed on is less than 0, this function will be called. I don't have that number of arguments here where it is passed on. Later on the script, I'm doing a comparison. First, you have to define the function, then later on you use it. And right here, I call the function based on the number of argument is passed. It is called, if the number of argument is less than 1, this pound $sign pound is the number of argument that's passed to this script. So if that number is less than 1, then it gives a usage which calls that function. Otherwise, it's going to do some other functions. So if the number of argument is less than 1, which is just a script name without any argument, then it's going to call this usage function, and it's going to produce this syntax saying that you need $0, in this case is the base name, which is the name of the script. So you don't have to say the name of the script. You say $0, the system automatically knows that user-defined variables or versus system-defined. $0 is a system-defined variable, and $1 is a system-defined variable. $arg1 is a user-defined variable. So if I'm just declaring those ones, then it will be different. So at this time, I'm trying to call that function, and if that function is provided properly with the argument, number of argument I'm expecting, and then if it is at least one argument, then it's gonna call this function, one args, and it does something with that one args. It is the one arg function, it sets the value locally. If you see this variable called local arg1 is equal to 100, that means that within the scope of this function one arg, which is from this brace, starting brace to the end of brace, this local arg1 is every time you refer to that one, it will have a value of 100. Outside of that one, the scope of this arg1 will be lost because I'm defining it with variable local. So that means that this will be initially set to 100 inside of this script. And then outside of it, if I'm using arg1 and I'm assigning $1 to it, whatever the parameter were passed, at that time it will print that value. So now, let's say I'm admitting student as they come in. So if I make a little bit pause because I'm just admitting other students, or maybe reading the chat if anybody's communicating with me. So at this time, function multi-args is the second function that it takes multiple arguments. And then this one also set the value of local arg1 to 200 rather than 100. So when I'm inside the multi-args, the value of arg1 will print 200. And then the value of arg2 will be, arg1 will be 200 inside this function. I'm sorry, 200 inside this function, and on the one arg would be 100. So, and then once I'm outside of the scope of the function, I'm back to the main global area. I need to see the value of these arrays and values passed. So inside of the script, when you call a script, if you pass only one argument to it, that will be assigned to $1. Second argument would be assigned to $2. Third argument will be assigned to $3, and so on. And then $@ is the array of all lists. So if there's 3 arguments, $@ will have a value of 1, 2, 3 if 1 and 2 and 3 were passed to it. At the same time, $@ and $star are pointing to the same number of arguments that are passed. So whether you use $@ as an array or $star meaning everything which is passed on, that is the same. $pound is the number of arguments. $1, 2, 3 is for each number of arguments that are passed in. 1 for 1, 2 for 2, and so on. And we will go through the examples. You will see. So at this time, after I'm getting out of the loop, the functions, and then I did the main. Inside the main, I check for the number of arguments passed. If the number of arguments is passed only 1, then it's going to just print whatever the value of $1 was passed. So it is going to call one arg. If it is more than 1, then it's going to call multi-args. And then in this case, you see that's if-else statement. This is what is if statement is useful. You're comparing the $pound. If it's 1, call the function usage. If it's, if it's less than 1, call the function usage. Otherwise, call the function one argument, or else if one argument, and then else, if all fails, call them multi-args, which is more than one argument. So in this case, I'm also showing you example of it here, like one local and global variables. So at this time, when I'm just giving no arguments to it, it gives me the output of, okay, there was no argument to $1, no argument to $at an array, therefore it has to give a usage. So outside of this one and inside the programs, there was no argument passed, now it's gonna give a usage. It says $0 was the name of the script. It says $0, and then it requires at least one argument, as an example, or more than one argument. arg1, arg2, arg sub n, whatever number of arguments you want to pass on, you do that one. So now this time I'm using one argument when one argument is passed. At this time I'm going to say the name of the script argument is just one. This time it found the one argument, so it calls the function one arg. The one since the argument is at least one. Now it is gonna have to print what I entered. That says you entered one, but inside one argument function, I set the one arg1 to value of 100. So right here, when I'm inside of that function, I'm getting a value of 100 because that one was defined locally. That's local versus global. Once I am out of that function, I'm in the scope of the other function. You can see all done with the scope of one argument function. At this time, arg1 is not 100 anymore because it's going to come to the outside of the program, which is the global area. And as a result, arg1 is what I passed into the script. So that's how, and then the add array, because I provided one argument, is going to say is equal 1. So next example is when two arguments are passed. 1 and 2 is passed. Notice at this time, the function 1 is not called because it's more than one argument. So it comes to the multi-function. In this case, it's going to come in, it prints out on the global area 1 and 2. Those are what I entered as input right here. So it prints out those two, and then it has to come into the multi-args functions. When it comes to multi-arg functions, at this time arg1 is equal 1 because that's what I passed, and then at arg1 and 2 has an array of it. You entered 1 and then you entered 2, but the value of the arg1 locally, I'm setting it to 200. So therefore arg1 is equal to inside, because if you look at the syntax, I print out these one first before I change it to arg1 is equal to 100. And there, let me go to the multi-arg. Let me check on the waiting room. There's more than a few people. Jonathan. Okay, that's good. So multi-args, when we are doing the multi-args, notice I print that one, what was passed first. I have not changed the global variable. That's why you get the value first. Now, when let's change the arg1 locally to 200, at this time it becomes locally. Since I use the word local, that means that it's only defined within local. So if I go back to the result of that script to check what I'm passing on, 1 and 2. This is the example that we were looking at earlier. So coming back here, notice that it prints 1 and 2 first. Then it says the value 200, now arg1 is equal to 200 because I'm inside the scope of the function multi-args. And now I'm all done with the scope of multi-args. So if I print out arg1, it's going to not be 200 anymore because it is outside in the global area of the program. So whatever I passed on is going to print out one. So arg1 was, instead of being 200, is equal 1. And then at is 1 and 2. Similar for 1, 2, 3. If I pass more than one argument, you can see now it becomes more clear that arg1 is passed on as 1, and then this is what you entered, 1, 2, 3. And then inside multi-args, it prints 1, 2, 3 first. Then it's going to say, now I set it locally to 200. Once I got out of the scope of that function, which is right here, and then I print out at and arg1. Arg1 is not anymore 200 because I'm on the global area section. And similar to this example, now I'm passing more arguments so it becomes more clear. Notice that $at, as many arguments as you passed on here, it's pointing to those values. And one is always $1. $1 is there, $2 is 2, $3 is 3, and $4 is number 4, and $5 is number 5. But $star means everything here, and $at means all of that, all of those 5 numbers. So all 5 arguments in this case. And then, so when I make the call, you can see it prints out all those 5 because we have a for statement there. And then I'm inside multi-args. It's still that locally it has to have a value of 200. Notice that it's going to be 200 because locally the scope is always 200. Outside of it, once I'm out of that multi-arg, is going to be the value that I passed on. 1 is going to be the first argument, 2 is second, and 3 is third argument, and so on. And then at and a star is pointing to everything. Okay, so then function global area, if I use the numbers or the string, doesn't matter. But it is on the example, you can see it's more clear. As when I use the number 1 for the arg1 or $1, the arg1 is pointing to 1, and then at is pointing to 1, and then you entered 1, and then locally, because 1 argument was passed, the value of arg1 is calling the function 1arg, and inside 1arg is 100. And then outside of it, it becomes 1 and 1 because there's only 1 argument is passed. In this case, number 1 as the argument. When 1 and 2 is passed, notice that at this time I'm using the multi-arg function rather than 1arg because more than 1 argument is passed. So 1 and 2 is printing 1 and 2, and then inside multi-arg function I'm using similar concept. Okay, and then for multi-arg, locally the value of arg was set to 200, and then outside of it is there, back to 1 and whatever I was passing it. So now I'm using example 1, 2, 3. You can see that the numbers are printed, but since it's multi-arg, the value locally for arg1, which is the first argument, is 200 again. Now, by giving these multiple examples, I made sure that you understand what is $arg1 is pointing to, what's $arg2, $arg3, and so on. And then at the same time, what is the array, at array, or this $star means the same thing. They're both pointing to the all parameters that are passed on. And then $pound, remember when we were checking saying that if number of argument is less than 1, so $pound is how many arguments are passed. If 1 and 2 is passed, the number of argument would be 2. If 1 and 2 and 3 will be passed, then the number of argument is pointing to 3. We will go through example on that one as well so you understand. $question mark or variables that are saying that the status of the function. If it is non-zero, all the function has to return a value. A value is either 0 or non-zero. If it is 0, means it successfully completed that command or that script or that function. If it's non-zero, it is not successful. Whether it's 1 or 127 or -1, that's non-zero. That means that a script or a command or function did not return successfully. A function always performs a task, and that function returns a value. That value has to be either successful or failure. So in the case of a script that you write or a built-in function you use, there's always a dollar sign question mark for bash and corn shell as sh. They're all pointing to dollar sign question mark. On C shell or TC shell, it's called a dollar sign status. If you look at the dollar sign status on C shell, you would know if that one was 0, then it means successfully completed. If it's non-zero, it's not successfully completed. So it's good to know these system variables. I'm having another topic that we define, like user-defined variables versus system-defined variables. System-defined variables are normally dollar sign something, like dollar sign point to your process ID. Dollar sign path maybe is your system path. Dollar sign LD library path would be your library path. And dollar sign maybe Java home would be your Java home. And Oracle ID is that pointing to the Oracle instance ID, and so on. A lot of those variables that you point to and that have a system-defined variable, they're normally in uppercase. Some of those ones are set in etc profile or etc.bash or C or customization configuration file .login, .logout, or any profiles, .env, whatever you call it, .vim or C or something, that you're setting those ones. And then there's user-defined variables that are normally in lowercase, variables like arg1 that you use in a variable, you set it to a value, and then you can unset it. There was 2 commands that we used on Unix normally. You should be familiar with both of them. One of them was env, which I'm going to give you an example after this, env, and the other one is print env. Env and print env is basically similar versus set. Set is showing you both global variable as well as local variable. env and print env are only showing you global variables, system-defined variables. And then there's set env also on C shell and TC shell. For whatever you do print env, if you want to print it and if you want to set the variable, you use set env. Equivalent to set env in bash, corn shell, and sh. Actually, bash and corn shell, they're similar. You use that word export. Export syntax for bash is different than the burn shell. The burn shell, you have to run it with 2 commands. For example, let's say you set your terminal to 100, you say VT100, you say term is equal VT100 semicolon export term. That way you set it. But on bash and corn shell, you could just do it in one line. You say export term is equal VT100. And on C shell or TC shell, you say set env space term space not equal space and then VT100. I'll show you an example after this also. But I wanted to discuss this one before we jump into that. Let me finish this example and then we go to the next one. And so function global area, at this time I'm providing like more than about 10 arguments. So you can see that it doesn't matter how many arguments I pass, the system knows that $@ or $* is having an array of all those arguments. So that's why at is an array of list. That list is 1 through 10 with some string for numbers. And then it prints out whatever I passed on exactly. So I'm going through the for statement and I say for I and n at array and then print I, and then therefore you have all of that. Arg1 is equal 1 in this case. Again, since I'm inside multi-arguments, the value of arg1 has to be 200 somewhere. Let me see where it is coming as 200. When I'm inside the function, so The first argument is locally to, yeah, right here. The value of argument is set to 200, arg1. And then as soon as I get out of the scope of multi-arg, now arg1 is back to 1 because that's global variable. So this explains that one. I'm going to show you this in actually CentOS or Ubuntu here. Let me just get into. Everybody could see my terminal, correct? Let me just go back to chat. I'm gonna stop sharing for a second. And can you put on chat that you see my screen? Okay, great. So everybody sees my screen. Now I'm gonna share the screen again. Let me see if any participation is waiting. Okay, everybody's here, that's good. I'm gonna share the screen again. And okay. Okay, so on here, I'm inside these functions. I have written a number of script for demonstration for you guys so you understand how to write functions and everything. One of the script was called the one that we did just now, function local global .sh. So I'm gonna just do a VI on that file quickly and explain. Let me just do this function underscore local global .sh. Okay, so I'm gonna go to line 1 by pressing escape and then shift colon number 1. It takes me an VI into line 1. And you can see this script. The nice thing about this one versus the Word document, this is all in a very nice format and colors because I set up my environment to have this kind of color and based on what I'm doing at what point. So arg1 is equal $1, which means it's coming for whatever argument. And then here I'm outside. This is outside of the function global area. And then right here, function usage is just a function. If you don't call this function, this is not even like it's declared. The system doesn't know anything about it. And it's not gonna complain. Some systems like Python and other programming language, if you define a function and you don't use it, sometimes you will see some sort of a warning or some error saying that you declare this variable or this function, but you never used it. But the way shell programming is almost like functional programming, because you could write your function here. Once you define your function, then you can use it later. If I just call, say, call the function usage here, let's say for some reason I just say, come in and say usage, right away the system is going to just have a problem because it doesn't know what this usage is. It's not going to go down and find it for me. In C programming language, you could write your main and then later on, wherever you write it, on the top, maybe you do some function prototyping, which you define the prototype and then later on you declare it. Or on Python, you could write the function and then use it as you go. And then here in Bash, you have to define it first, later on you use it. So this one is just giving you a usage. Remember, this $0 is pointing to the name of the program. In this case, the name of the program is function local global arg1 $, and then that's how it's going to print out. So if the program name was example1 $, it would say example1 $, followed by $1. And since there's more examples, I'm just giving you more example here. how to pass on arguments. And function 1arg is going to set the local variable 100 here. We already went through, and then $@ array is just printing. Notice that I'm using here escape, so I could just print out the $ followed by @ and similar here. If I just want to follow a certain word like $, then I have to escape the $. And then similar here. So here I'm using a for statement. Remember the for statement, if I had 10 arguments, it goes through this 10 argument because this is an array of list. Whatever argument was passed, it is in this array, but it's a list. And then it goes through that array of list, and it's going to print each one of them one. You entered arg1. Arg is, in this case, is my variable. Every time it just goes through the list of arguments. And then it prints it. And then here in this one, I'm setting variable 200. So, and then here the usage, I'm comparing if it's less than 1, call usage. If it's greater, equal to 1, exactly 1 argument passed, call this 1 argument function. If it's more than 1, then just do that one. Since I don't have another part, this else means more than 1 because I'm not comparing it anything else. So if it was 0 argument, automatically it would just say it's less than that, it would call the usage. So this if statement, if else, then else, that one is basically comparing all the condition that is matching. And then when I'm outside, I get out and then I print out what was feasible on the global area of the program at the end, and then I'm done with all of it. So let me just give you, like for example, example of the script that the script works. Like if I just don't give any argument, it clears the screen and then does it. Now I just run the same script, say test. And then since I gave 1 argument, my argument 1 was test, and then my @array is pointing to this array list, but there's no more, so it's only printing test. And then in this example, arg1 is locally set to 100. You notice? And then outside, it comes back, the arg1 is back to 100, back to test. Or arg1, I'm not printing it here. Because even if I print, yeah, I do actually. You print it, it's back to global area, which is 1, test. So if I just say Wahid testing this, doesn't matter what I put the argument, those will be calling the multi-line functions. Here it is all those 3 arguments. And then here is just all those 3 arguments, but inside the local argument, the arg1 is equal to 100. Okay, and then if I just do this, if I just gave a star, because a star means wildcard, and Unix, whenever you just say a star, that means everything. So $pound is also the $@ and $star is pointing to the same place. And a star means like this. If I just do ls a star, notice that all my scripts that are here are just listed. So if I do ls minus l star, the same thing as ls minus l. Or ls is the same as ls star, right? So, but notice that ls star is also looking at the directory inside the back. If I have more files, it will list them. So I could do something like this in terms of this, and instead of just giving that many arguments, I could just say this. Now it's gonna just take each one of my script name as an argument to it. See that? Now watch what happened. Because I provided more than 1 argument by just giving this a star, it reads all the variable that was inside here, and one of them, for example, it is back, fun, all those functions. It print out those ones, but then on the multi-args, it is still going to say arg1 is equal to 100. Okay, right here, arg1 is equal to 100 because I define inside the local variable arg1 inside that multi-arg functions to 200. So that's the difference between local variable and global variable. So if I just say touch this, and then I run the same star command, now it's going to be, this is also going to be in the list because right here, see, this is also somewhere on the top list. But the value of local variable on the arg1 is always 200 inside that function. Outside of that function is always whatever I passed on. So here you see that this right here, and then on top, of course, it's there too, somewhere there. Yeah, right here. And then inside that one multi-arg function, the value of arg1 is equal to 200. But once I'm out of that scope of that function back to the global area, that arg1 is equal whatever I passed on. In this case, since it matches my first argument, back will be printed as arg1. So if I just gave this one and say 55 and this, notice 55 will be the last argument that is going to be printed because $1 is that one. And then inside that multi-arg is still 200. If I do it with one argument and say just 55, this is going to be 100 because I'm inside one arg, not multi-arg functions. I hope that is clear. I think I covered enough for that one. So I'm going to just show you another script that's called env, very small script, MyEnv. So let me see more, MyEnv.sh. Yeah, look at this, it's only one line command. So whether I type in env here or MyEnv, it is the MyEnv.sh, it is the same. It prints out the environment. So I was telling you earlier, print env, env, or the same command. Set is also showing you all the global variable, local variable, everything that is set is there. So the way set works, there's set and unset. There's set env and set env. There's export command also. So let me show you an example of set. First let's say I say x is equal 5, and then I say x $x. Now I print out. At this time I'm going to say unset x. Now if I just say echo $x, it does not have any value because I just unset it. So that's theirs. If I'm on inside C shell, I could say set env x is equal 5. Notice that inside the C shell, I went to C shell, my prompt changed, and if I do echo $, I'm inside the C shell. How do I know that one? Inside my bash was the main process, and then C shell was a sub shell that I opened. And that process ID is the same as my C shell. So $. If I just say unset env x, now I just say echo $x. It's not set. Okay, so then I go back out of this one. Okay, also remember I was telling you that there are certain variables that you have to set whenever you're using VI editorial term. Sometimes if you're in an X window session and you're coming in and there, you might have to set the environment in order to be able to edit a file properly. Sometimes you get a lot of garbage on the terminal, and you have to set these variables. So if you're on C shell, you do set env term VT100, set env visual vi, set env editor vi. These three are the most important one, aside from display and other ones, that every time you go inside vi or emacs or something, if you cannot edit the file properly, that means your terminal or not VT100, or your visual is not vi and or editorial. And then you set it, then you just vi a file, let's say test.txt, and then you have fine, everything is fine, and you just come back, quit out of that one, you come back. So now I'm gonna exit out of this. Inside the bash, equal $bash, sorry, $, you can see it's my process ID of bash. Remember that get env password, and then wlutfi pass word, pass wd, no, I'm sorry, pass wd, and then password, and then wlutfi. So by default, my bash is my shell that I'm using. So I'm gonna just do run some commands. Here, if I just say x is equal 5, and then I say export x, that would do it, and like similar to what I do it on C shell. But I could do it both of that command one command, export x is equal 10, and then echo $x. I just changed it from 5 to 10. So when you're defining a variable in bash, you can use in one syntax, export x is equal 10. On the C shell, it was set env x is not equal x, and then a space 10. That's the syntax. So in this case, if I want to set my export term, visual, everything, I could do like this, term, it has to be in uppercase, term is equal VT100. And if I want to do all of them in one line, I could do this, VI, and then export editor VI. So now I set up all three, but somewhere I wrote export wrong. Let me just correct that. Let me go back again. Export term is equal VT100. Export editor is equal VI, and semicolon, export visual is equal VI. Now say env, and then if I just want to say grep editor, let's say I just want to see both of them, I could just say VI, whatever other one besides visual and editor was set, it will list them. In this case, a lot of things are using the word VI, like right here is that symbol match, and then these three and match. So if I'm just interested in those ones, env, and then I want to see only those three, I could use egrep. Okay, I could say egrep, and then I put vi. Okay, since the word is I don't want this avi, I could say is equal vi, or visual, or I could just put the word editor pipe visual pipe term. Those three, and those three. Now this color term, and then these other ones are there, so I could just say I'm only interested in the word -w, and those three are the one that I want to do. So notice how flexible Unix is in terms of what you want and how you pick up certain things. It's so easy in life, you could make it. Like for example, now if you want to just get the editorial and then equal value and change it. I'll show you a trick that I did for this other script. Let me see if the script is here. No, actually the script is in my website. Let me just show you that one. So I'm gonna go back to the session here, and since we already discussed this one, let me close this. Okay, I'm gonna close this one, and okay, go back here, make it maximum. Next one, let's see what we have on the topic that we could cover. Bash script using the scope of function. Actually, we went through global and local. So you know when you're inside the function, the scope of them only defined with the function. As long as you pass the same $1 argument to the function and you did not use the word local, that would be global, disregard to whether you're inside the function or outside of the function. But if you're in the scope of a function and you want to just the variable to be lost after you exit out of the function, then you have to define the local in front of the variable declaration. That's very, very important with the scope. So we went through a number of examples. You know that one already. Let me see what other things I put on the topic. Bash scripting, how to call a function. Okay, calling a function is important. And remember when we call in the usage function or one argument or two arguments, one thing that I was not showing you maybe as an example, the usage function, you just give the name of the function. Like you say, if $pound is less than the number of arguments, then just call a usage function. And then it will just call that function. But if it's more than one function, more than one argument, you're not putting it within the parentheses of the function like other programming language you do. In Bash scripting, you basically gave the name of the function followed by the argument 1, argument 2, and argument 3, and so on, followed by spaces. That separated by spaces. That's all that matters. So I'm going to show you on an example here. There's a function called usage. Usage, I wrote this one to just demonstrate only one function when it's argument or passed. So as you can see, this script, the way it does the shebang in bin bash. Why I put it bin bash? If I do which bash, it's going to show me the path to bash. So this line is going to find my bash interpreter. Then every line that I put here, it has to adhere the syntax of bash interpreter. And then if it is correct syntax, it would work. Well, the first line, it says some comments, what this usage function is. Then I have function usage. This is a function. If I don't call it again, it will not be just as if it's not defined. But it is defined there, so I can call it. If I don't give any argument to the function, that means I'm just calling this usage function. And it's gonna, at this time, if I say a number of arguments less than 1, if no argument was given, then this function jumps back here and clears the screen and does the usage, all of these, and then exits out. Then it's important to exit out. Otherwise, you don't want the user to just not be able to enter anything after because it locks up on him on waiting for something else that they don't know what they're doing. So at this time, it gives a usage. But if the number of arguments was passed, remember I was telling you that $* and $@ is the same thing. So in this case, I'm just, if more than one argument was passed, or one argument at least was passed, then I'm going to print that arguments. So $star in this case is going to print it. So if I say usage.sh, again, usage.sh has to be executable. We already talked about it previously. So in this case, the owner is wlutfi. The wlutfi has read, write, execute permissions. The group is also wlutfi. The wlutfi also, the group wlutfi has read and execute. This dash means the group cannot write to it. And then everybody else but user ID and group ID matching that is considered as everybody else. Developers, anybody on the system, including root. So everybody has a read, no write, no execution. Remember I said including root, but root has higher privilege than this user. So disregard to, even if I put dashes here, anything for the others, root could still do whatever they want to do with this file, because root has permissions of 0 ID and group ID of 0. So if I look at this one, password, this is the UID of root, which is 0, group ID of, that is a unique UID, group ID with the highest privilege for root, and saying that no matter who gave me what permission, if I become root, I could do whatever I want. And the way you could do root is you do su-root, so it's user-root, and then you provide the password to root. Or sudo, if you're on the sudo list, and then you could do sudo su dash, so it's user to root. You could do that, those two commands to do it. At this time, I'm just showing you that this permission or set executable. If let's say the permission of this one was 644, by default, every script that you create, usage.sh, usage.sh. I remember I was telling you that by default, it looks at your umask. So since the umask is 022, the first time that I create the script, it is a 6 minus 0 is a read, right? And then for the in dash, for the first one is 6, and then the next one is 4, because 6 minus 2 is 4, so R is readable, and this is also for other people readable. So in this case, I'm going to change the permission. I could do 755 usage.sh, and that would show usage.sh to back to 77. Or if I just say change it to 644, now let's say I want to change mode to plus X usage.sh. That plus X means whatever was on this current one, add an X with it, make it executable for everybody else. So that's similar to 755. Notice that since I already had read write execute for everybody, read access for everybody and read write for the owner, I only added the X there. So usage.sh has X. Now if I run it, usage.sh is going to just say, I need some argument. Now I'm going to just say arg1. It just says, oh, you're entered arg1, $star is going to point to that. Say arg2, and so on. So if I just change this one to numbers, 1, 2, 3, 4, whatever, 3, 4, 5, whatever number I put, it's going to just print out those ones. It doesn't matter what I put in. And then at this time, if I just say star, whatever number of files here on this directory is going to do the same thing. So remember, this star means everything. Now I'm going to just get the output like similar to what I got.